Hello everyone, this question has been taken from Olympiad Pathfinder, multiple choice question number 28, belonging to chapter 2 and related to Newton's law of motion. In the question it is given two balls of equal volume and masses m1 and m2 where m2 is greater than m1 connected with a thin light thread are dropped from a certain height. Viscous drag of air on a ball depends on its velocity, and the buoyant force is equal to the weight of air displaced by the ball. So when the balls acquire a uniform velocity after a sufficient time from the instant they were dropped, what is the tensile force in the thread? Acceleration due to gravity is to be taken as g, and there are four options, so we have to solve it. Okay, so let us discuss this question and try to solve it. Free body diagram of both the ball moving together with uniform velocity, because in the question it is giving that after sufficient time both the balls were moving with uniform velocity, okay, and during which the thread were tight, right? So free body diagram you can see here. This is your ball 1 with mass m1. Which all forces are acting on it is the weight acting downward, air drag in the upward direction, buoyancy force in the upward direction, and v is the uniform velocity by which it is coming down. Since this is a thin light thread, so tension at each and every point in the thread will be same. So at this point also where it is connected to ball 2, the thread will have a tension T which will be acting upward, air drag will be acting upward, buoyancy force will be acting upward, and weight is acting downward. And velocity of this ball also is v as per the question. So your air drag force is entirely depending on the velocity. So for both the ball, velocity is same, therefore air drag force will be equal. Okay, buoyancy force is depending on the weight of the air displaced by the ball. Volume of both the ball are given that they are equal, so therefore weight of the air also displaced by the ball 1 and 2 will be equal. So buoyancy force Fb will also be equal. So we can write now equation of motion for ball 1 and similarly for ball 2. So ball 1, if you see, it's m1g is acting downward, t is acting downward, so m1g plus t. Fa is acting upward, so minus Fa. Fb is acting upward, so minus Fb. And there is no acceleration because both the balls are moving down with uniform velocity, so this will be equal to 0. Similarly for ball 2, weight is acting downward, m2g, tensile force acting on ball is, and which is exerted by the thread is minus t because it is acting upward, air drag acting upwards minus Fa, buoyancy force acting upwards minus Fb. Again going down with uniform velocity, so no acceleration, therefore it will be equal to 0. So from equation 3 and 4 you will easily you can calculate that t is equal to m2 minus m1 into g into 0.5. And if you go and see in the options, so D is the options where it is matching with the outcome of tensile force over here. So our answer is D. So hopefully you understood the concept easily. Even if you have any doubts, so please write in the comment box. I will reply on that. Thank you.